All right, in our first video, we are going to solve a system of equations. That's very, very common. We're actually going to learn three different ways to solve a system. So often when we have a system, we want to solve it. We want to know what the point of intersection is. So what is the solution to this system of equations? One of our solving methods is to graph them both. Graph the two lines, let's see where they cross. So we're going to graph the line y equals negative 2x minus 4. That line is ready to graph. We can identify the slope is a negative 2 and the y-intercept is a negative 4, so 0, negative 4. We can go ahead and put that graph or that line on our graph, starting with the y-intercept at negative 4. And then from there, a slope of negative 2, so down 2 to the right 1. When you run out of graph, you can go the other way. And then we'll just get this line on our graph. And when we draw the line in, you want to draw it as neatly as you can. If you have a straight edge of any kind, that makes this a little bit easier. I don't have that option when making the video, so I will just try my best to draw a straight line. Okay, so there's one line. The system has another equation, y equals 0.5x plus 6. I'm actually going to rewrite that. I don't like decimal slopes. I like to see a rise over a run, but I recognize that 0.5 is the same thing as 1/2. So I'm just going to write it as 1/2 x plus 6. Our slope is that positive 1/2, and the y-intercept is that positive 6, so that's the ordered pair 0, 6. To graph this line, go to your graph on the y-axis. We start at the positive 6. You go up 6, plot your point, and then from there a slope of 1/2. So the rise is 1, the run is 2. Remember, we always run to the right, so up 1 to the right 2, and then we can backtrack and get the points the other direction. Now I notice in this spot right here, I plotted a point that was on the other line, and it's a nice exact point. That means when we draw on our line, the solution is that point of intersection. And when I look at my graph, because my graph is, my lines aren't drawn perfectly, it might be hard to tell, but I know that I landed at that exact spot right on the other line. So the ordered pair is going to be the solution. And if we go from the origin, the x, we go to the left, 1, 2, 3, 4, and we go up, 1, 2, 3, 4. So the solution is the ordered pair, negative 4, comma 4. And that's how you can solve a system of equations by graphing. Now, let's say you wanted to be extra careful and just make sure that you actually got the correct solution, because we could have graphed one of these lines incorrectly and we would have come up with a different solution. Just like equations, you can always check your answer. This x and this y should work out in both equations. So if we take a look at our first equation is y equals negative 2x minus 4. Let's plug in the x and y and see if it works out. So the y is a 4 equals negative 2 times the x, which is a negative 4, and then I'm going to carry down the minus 4. So 4 equals the negative 2 times negative 4 is a positive 8, minus 4, and then we can do 8 minus 4 on the right, and we get 4. And it worked out. What that means is that our solution is on this line. That doesn't tell us if it's also on the second line, so we do need to plug it into the second equation if we do want to just do that check to see if we got the correct answer. That was a 1/2 x plus 6. So let's plug in the points. 4 equals 1/2 times the x, which is a negative 4, plus 6. 1/2 times negative 4 is negative 2. So we have 4 equals negative 2 plus 6 is a positive 4, and it worked out for that equation as well. So that means that our ordered pair is on this line and it's on this line, and so we can tell that that point is the one point that is on both lines. It's that point of intersection. So that's the solution to our system, and we found it by using the method of graphing.